Python is a general purpose programming language that's now becoming more popular within the data analytics and data science industry. So companies over the world leverage Python to harvest insights from their data sets and have a competitive advantage against their competitors. So in this Python for data analysis or data science, we're learning all about the powerful ways to store, manipulate, and gain helpful insights within our data set using Python programming language. So welcome back to the channel and welcome back to Excel Island, where the goal and objective is to learn and master Python for data analysis over the next 100 days. Today is day 3. So we've been showing up consistently over the past 3 days. So when we started from the beginning of the introduction to Python, we got introduced to data types and variables on day 1. So you can catch those lessons on the live stream tab on the channel. So on day 2, we started with lists, manipulating lists, slicing and dicing, adding lists, removing lists, and building lists in Python. It was a pretty long, over an hour, a live stream learning journey on day 2. So today on day 3, we are moving to function and packages to effectively leverage Python. So we're looking at all the functions, probably not all the functions in one sitting, but we're starting with functions that are available within Python, the packages in Python, so you can effectively leverage Python for data analysis. So all data sets, exercise files, Power BI files that we'll continue to be using and will be using is already linked under the YouTube description. Make sure to download those files, practice along with me. So without further ado, welcome back to day 3 of Python for data analysis. Let's jump back to learning. So I'll just go back to my DataCamp dashboard and show you where we stopped on day 1 and day 2. So from day 2, we're going to continue from day 2 actually. Just a moment there. I'll be showing less of my face today because I'm trying to manage some of my resources. Right. So I'll just switch on quick. And we go, if you go under the section, this career tag section in DataCamp platform, so we could see that we have data analysis with Python right here. So when I started this fun way of learning, as I usually say, it all started with associate data analysis in SQL, which we completed that for a 100-day period. And we have data analysis in Power BI also, which was the last learning journey live stream that we actually completed. So we are moving to data analysis with Python. So these are the 3 amazing tools we plan to upskill myself on this 2024. I'm currently a corporate plus data analyst, freelance data analyst actually on the Upwork platform. So I'm currently looking to upskill myself and and have a competitive advantage as a freelancer or out there. You have to keep upskilling yourself. So I'm looking to upskill myself in these 3 tools this year. So amazingly, I'm on the last goal for this year, which is Python for data analysis. So I click on that really quick. You could see that it contains 36 hours of learning. And I usually say definitely you're going to spend more than that. It contains 9 courses, 2 skills assessments, 5 projects, and over 59,000 students have taken it. So we all started with introduction to Python. We are on introduction to Python. We completed the Python basics, which talked about variables and data types in Python. We discussed Python lists on day 2, which was all about creating lists, adding and removing values from your lists and manipulating lists in general. We're moving to functions and packages today, so we just continue from here without any other delay. Okay. So this was all we did yesterday. That's like 24 hours ago, which was all about lists, changing elements in the list, slicing and updating lists, adding list elements, deleting lists. We also learned about copying lists and using lists from another list like you're copying. So it was pretty tricky there. I think I spent a little bit of time to comprehend how to copy lists. And when you copy lists and you made an update to the copied version, it won't affect the, but it was amazing. It was a learning curve for me on that day too. So that's what we did yesterday. You can catch the full details of this on day 2 learning. So let's continue from functions and packages in Python.
In this video, I'm going to introduce you to functions. Once you learn about them, you won't be able to stop using them. I sure can't. Functions aren't entirely new for you, actually. You've already used them. Type, for example, is a function that returns the type of a value. But what is a function? Simply put, a function is a piece of reusable code aimed at solving a particular task. You can call functions instead of having to write code yourself. Maybe an example can clarify things here. Suppose you have the list containing only the heights of your family, fam, and say that you want to get the maximum value in this list. Instead of writing your own piece of Python code that goes through the list and finds the highest value, you can also use Python's max function. This is one of Python's built-in functions, just like type. We simply pass fam to max inside parentheses. The output makes sense. 1.89, the highest number in the list. Max worked kind of like a black box here. You passed it a list, then the implementation of max, that you don't know, did its magic and produced an output. How max actually did this is not important to you. It just does what it's supposed to, and you didn't have to write your own code, which made your life easier. Of course, it's possible to also assign the result of a function call to a new variable. Now, tallest is just like any other variable. You can use it to continue your fancy calculations. Another one of these built-in functions is round. It takes two inputs. First, a number you want to round, and second, the precision with which to round, which is how many digits after the decimal points you want to keep. Say you want to round 1.68 to one decimal place. The first input is 1.68, the second input is 1. You separate the inputs with a comma. But wait, there's more. It's perfectly possible to call the round function with only one input, like this. This time, Python figured out that you didn't specify the second input and automatically chooses to round the number to the closest integer. To understand why both approaches work, let's open up the documentation. You can do this with yet another function, help, like this. It appears that round takes two inputs. In Python, these inputs, also called arguments, have names, number and n digits. When you call the function round with these two inputs, Python matches inputs to their arguments. Number is set to 1.68 and n digits is set to 1. Next, the round function does its calculations with number and n digits as if they are Python variables in a script. We don't know exactly what code Python executes. What is important, though, is that the function produces an output, namely the number 1.68 rounded to one decimal place. If you call the function round with only one input, Python again tries to match the inputs to the arguments. There's no input to match to the n digits argument though. Luckily, the internal machinery of the round function knows how to handle this. When n digits is not specified, the function simply rounds to the closest integer and returns that integer. That's why we got the number 2. In other words, n digits is an optional argument. This tells us that you can call round in this form as well as in this one. By now, you have an idea about how to use max and round, but how could you know that a function such as round exists in Python place? Well, this is something you'll learn with time. Whenever you end a task in Python, you can be pretty sure that there's already a function that can do this for you. In that case, you should definitely use it. Just do a quick internet search and you'll find the function you need with a nice usage example. And there is, of course, DataCamp, where you'll also learn about powerful functions and how to use them. Get straight to it in the interactive exercises, and I'll see you back here soon.
That's pretty straightforward. But uh, this part is actually focusing on different functions in Python. Let me just launch my Jupyter notebook real quick. I'll just launch my Jupyter notebook. So I continue and where I stopped yesterday. So if you're looking to download the Jupyter Notebook, so on day one, you could watch the video on day one, where I showed you a video that will help you on how to download the Jupyter Notebook, this Anaconda rather, that contains different Python packages like Jupyter Lab, Jupyter Notebook, or Spider, um, Visual Code, and R, even R is there. So this is R language. So you could, so just go to day one of this challenge. You see where I recommended the video for you on how to do that. If I just go to my Python file, I just have to launch my Jupyter into to Python file. I just launched it, the Jupyter Notebook there. Maybe. So this was what we learned on day one, which was just variables in Python, variables and data types, variables and data types. I just want the code, it's just going to run like that. So this was all the example that we did. So on day two, that was where we moved to Python list in Python. So on day three, now just create a markdown for this, just to make the code easy. We're looking at functions and packages. And packages in Python. Just on the code, it's just going to be like a markdown, like a sub, like heading for us to know the difference between this bunch of codes. So let's move on. So it says familiar functions. So out of the box, Python offers a bunch of built-in functions to make your life as a data scientist easier. So you already know two such functions, which is print, type. So these are functions. There are also functions like string, int, boolean, float to switch between data types. So these are built-in functions as well. Calling a function is easy. To get the type of 3.0 and store the output as a new variable result, you can use the following. Result equals to type 3.0. Okay, so instruction. Use print in combination with type to print out the type of variable 1. So we have variable 1 here. Variable 1. This is like a list. And we already know that this is a list already from previous knowledge. And this is also an integer data type. So what we need to do, you can say, okay, results. We use the result variable results. Let's get a variable called results. It's going to be equal to type. Want to get a type of type of variable one. That'll give us type of variable one. So use len to get the length of the list variable one. Wrap it in a print func to call to directly print it out. So wrap it in a print to directly print it out. So we have print out length of variable one. We're going to get the length first. We just the length function. If you're familiar with uh Power BI functions, Excel function, these are all familiar functions also. We're going to be len var one. So to print it out, we're going to wrap the whole len in print function. In a print function like that. So finally convert this and say use int to convert variable 2 to an integer. Store the output as out2. To convert variable 2 to an integer. So variable 2. So we're going to say int is going to be variable 2 for that. So let's run the code and see if our results will be correct. Okay, run code. So you can see. So print data type for variable one. Let's say I think it's still printing. Okay. Create a variable. It's created a variable. Variable one. So print out type of variable one. Okay. Let's see, something is missing here. So it convert this one to hold up. My type function here. See, there's a mistake here. Okay. Let's run the code again. Oh, this time I'm still getting same value. So if I try to submit it, let's if I try to submit it, there's an error somewhere. So incorrect submission. Make sure to print out type of variable one with print type variable one. Oh, get it now. You can see my mistake there. So I was supposed to use print, then the type of the variable. Let me just copy the code real quick. Control C and reset the shell. I couldn't reset this one also. I thought this will also reset. Now let's see it again. So you can see that hold up here. The print type variable one, print out length of variable one, convert variable two to an integer. So the class the class is a list. So the type here is a list, which is the print of variable one. Then we've counted the length of variable one, which is 4. You can see the results here. So we are correct now. Let's see that in action. Boom. Let me just copy this to my Jupyter notebook here and see it in action again. So once we get the variable type for variable one, which is a list already, they want to get the length of variable one. Also, then we converted this variable to an integer data type here. So if I run the code now, let's see what we have here. You can see class is list, then the length of variable one is 4. It's a great job. The length function is extremely useful. It also works on strings to count the number of characters. Okay, characters rather. So let's continue. So help. Maybe you already know the name of a Python function, but you still have to figure out how to use it. Ironically, you have to ask for information about a function with another function, help. So in IPython, specifically, you can also use question mark before the function name. So to help on the max function, for example, you can use one of these calls, help max or question mark max. So use the IPython shell to open up documentation on POW. Do this, do this type, do this by typing either POW or lpow and hitting enter. So which of the following statements is true? Let's see. Help, let's type help. Then the function is POW. Let's hit enter. So it says help on building function POW in module buildings. POW. So the argument is base, expression, mode. So this will say the mode. So equivalent to base expression with 2 arguments, or base expression times expression percentage mode with 3 arguments. So some types such as int more efficient algorithm when invoked using 3 argument form. So it says pow. Let me try this again on Jupyter notebook. Okay, use the question mark here and type pow. Let's see. So signature, so it's perform the same thing. Okay, let me use help. Then I type the function pow. Let's see if we're going to get same results. So which one's kind of cool? This or this? This one is saying signature base wow base expression mode none. So the doc string, so equivalent to base with two argument or base, almost the same thing. It's not even almost the same, it's exactly the same thing. So some types such as int are able to use a more efficient algorithm when invoked using the three argument form. So it's not giving help more information about the function though. So you still have to really understand what it is saying. I think I'll prefer the internet though. If I could use this to figure out the what a function does, I could just paste it on Google. Just paste this on Google to have a more understanding of. So explore more translate. Okay, interesting. Yeah. So it says file takes three arguments, base, expression, and mode. Without mode, the function will return an error. This is wrong. It will return an error. So Power takes three required arguments, base, expression, and none. No. Power has, hold up a minute there. Okay, I'm back. Okay. So it's saying Power takes three arguments, expression, and mode. Missing expression results in an error. No. One of the- So Power requires base and expression argument. Mode is optional. So mode is optional. I'll go for this. Alright, so perfect. So help. So help can help you understand how function work, unleashing their full potential. So that's what we can do with the help function there. Okay, so let's continue. So multiple arguments. So in the previous exercise, you identified optional argument documentation with help. You will now apply this to change the behavior of the sorted function. So have a look at the documentation sorted by typing help sorted in the IPython shell. Let's type help sorted and see it in action. From the name, you know that it is going to sort. Let's see. So help on building function sorted in module buildings. So sorted, it has the iterable, comma, slash, comma, star, comma, key, none, reverse, false. Ooh. Return a new list containing all items from iterable in ascending order. Okay. So a custom key function can be supplied to customize the sorted order, and the reverse flag can be set to request the result in descending order. Oh, oh, that's so much to take in. Oh, let me see. I didn't see that. So this was what I was reading. Okay, let's look at it. So in the previous exercise, you identified optional argument by viewing the documentation with help. You now apply this to change the behavior of the sorted function. Okay, so have a look at the documentation of sorted. We did that by typing help sorted in the IPython shell. You'll see that sorted takes three arguments: iterable, key, and reverse. What about these arguments here? In this exercise, you only have to specify iterable and reverse, not key. Okay, so lists have been created for you. Can you paste them together and sort them in descending order? Okay, can use the sorted function to paste two lists together and sort them in descending order. Okay, maybe we use full lists. That should be okay. That's quite straightforward. Use the plus to merge the content of first and second. So that just be full should be first and second. Okay, and second here. So sort full in descending order, full sorted. We want to sort it in descending order. So we're now going to say we call sorted and on full and specify the reverse argument to be true. Save the result list as full sorted. We're going to say okay. I'm going to type sorted. No, I'm going to use the function sorted. So I'll now call the sorted on full or the full comma. Then the reverse is going to be 2. Reverse should be equals to 2. I think so. Let's see. So it's going to sort it in descending order. Reverse is 2. It's going to sort it in descending order. Descending order. I can see 11.518. And let's see. Now let me now print out fully sorted. Print fully sorted, which is this last list here. Let's see it in action. Ooh, error, come on. Where is the error? I think maybe I didn't mention reverse here. This one said you see the sorted text tree argument, iterable key and reverse. In this exercise, you only have to specify the iterable and reverse, not key. Okay. All sorted and on full and specify the reverse argument to be true. So reverse, okay, why? Because I didn't input reverse there. Reverse equals to 2. Let's see it again. Exactly. So I'm going to mention the reverse keyword also and specify to either true or false from the name here, reverse. Interesting. You can see that my key now, my list now is now sorted from in the center, that is from highest to lowest. You can see 20.0, 18.0, 11.5, 10.75, then 9.75. Interesting. Let's see if you are correct. Boom. We nailed this. So that's how to use sorted in Python. Let me just paste it here in my Jupyter notebook here and see it in action. We created a list first and second. So we've joined the list together using the plus sign. So we actually sorted the list in reversed order, like from highest to lowest. So we printed out the list with print function. You can see now. Okay, cool. That is easy peasy there. Oh, so let's move to methods in Python. Let's see what we have here.
Built-in functions are only one part of the Python story. You already know about functions such as max to get the maximum of a list, len to get the length of a list or a string, and so on. But what about other basic things such as getting the index of a specific element in the list or reversing a list? You can look for built-in functions that do this, but you won't find them. In the past exercises, you've already created a bunch of variables. Among other Python types, you've created strings, floats, and lists, like the ones you see here. Each one of these values or data structures are so-called Python objects. This string is an object. This float is an object. But this list is also, you got it, an object. These objects have a specific type that you already know: string, float, and list. And of course, they represent the values you gave them, such as Liz, 1.73, and an entire list. But in addition to this, Python objects also come with a bunch of so-called methods. You can think of methods as functions that belong to Python objects. A Python object of type string has methods such as capitalize and replace. But also, objects of type float and list have specific methods depending on the type. Enough for the theory now. Let's try to use a method. Suppose you want to get the index of the string mum in the fam list. Fam is a Python object with the type list and has a method named index. To call the method, you use the dot notation like this. The only input is the string mum, the element you want to get the index for. Python returns 4, which indeed is the index of the string mum. I called the index method on the fam list here, and the output was 4. Similarly, I can use the count method on the fam list to count the number of times 1.73 occurs in the list. Python gives me 1, which makes sense because only Liz is 1.73 meters tall. But lists are not the only Python objects that have associated methods. Also, floats, integers, booleans, and strings are Python objects that have specific methods associated with them. Take the variable sister, for example, that represents a string. You can call the method capitalize on sister without any inputs. It returns a string where the first letter is capitalized now. Or what if you wanted to replace some parts of the string with other parts? Not a problem. Just call the method replace on sister with two appropriate inputs. In the output, Z is replaced with SA. To be absolutely clear, in Python, everything is an object, and each object has specified methods associated. Depending on the type of the object, list, string, float, whatever, the available methods are different. Sister has a replace method, but a list like fam doesn't have this, as you can see from this error. Objects of different types can have methods with the same name. Take the index method. It's available for both strings and lists. If you call it on a string, you get the index of the letters in the string. If you call it on a list, you get the index of the element in the list. This means that, depending on the type of the object, the methods behave differently. Before I unleash you on some exercises on methods, there's one more thing I want to tell you. Some methods can change the objects they're called on. Let's retake the fam list and call the append method on it. As the input, we pass a string we want to add to the list. Python doesn't generate an output, but if we check the fam list again, we see that it has been extended with the string me. Let's do this again, this time to add my height to the list. Again, the fam list was extended. This is pretty cool because you can write very concise code to update your data structures on the fly, but it can also be pretty dangerous. Some method calls don't change the object they're called on, while others do, so watch out. Let's take a step back here and summarize this. You have Python functions like type, max, and round that you can call like this. There are also methods which are functions that are specific to Python objects. Depending on the type of the Python object you're dealing with, you'll be able to use different methods and they behave differently. You can call methods on the objects with the dot notation, like this, for example. There's much more to tell about Python objects, methods, and how Python works internally. But for now, let's stick to what I've talked about here. It's time to get to some exercises and add methods to your ever-growing skill set. Let's get you coding again.
Oh, I think the main challenge here is to know the methods for each object or data type. But to know how many methods a data type, because everything is an object in Python, fine. You could easily know the data type of the objects. How do you know how many methods those object or data type has or have or contain or whatever English word you want to use? So let's go to strings method though. So string comes with a bunch of methods. Follow the instruction closely to discover some of them. So if you want to discover them in more detail, that's cool. You can always type help string in the Python shell. So a string place has already been created for you to experiment with. So use the upper method on place and store the result in place up. Use the syntax for calling methods that you learned in the previous. Okay, let's load up. It said use upper method on place and store the results in place of upper method. So once you want to make the pull out probably the first letter there a upper letter or all the whole content. You want to make it upper. Exactly. You want to make all the whole content to be in upper. So I'm going to say place dot upper. Open and close brackets, first order the images. So you're going to so print out place and place up. I'm going to say print place. So it's going to be the next one is going to be print place up. So we're going to see the smaller version and the upper version. Print out the number of O's in place of. So the next one is say print out the number of O's in the variable place. by calling it dot count on place and passing the length to the method. We are talking about the variable place, not the word place. Okay. So we want to count the number of O's in place. So I want to use the count function here, or the dot count method rather. Not the dot. I'm going to say place dot count. So I probably do not need to put the figure here. Okay, print out the number of O's in the variable place by calling dot count on place. Okay, and passing the letter O. So it's okay, count O. Now count O, okay, as an input to the method. We are talking about the variable place, not the word place. So I'm not going to say it should print it out. Let's say print, open it, and close the bracket. This is quite tricky though. Let's see. Ooh, error. Come on. Why am I getting error? Hold up, hold up. So I've gotten my pull house and pull house, but I didn't get this print out the number of O's in counts. Okay. Okay, so we don't have like 3 O's there. Let's see if I'm making it too much error there. So I'm guessing it says name error. O is not defined. Come on, come on, come on, come on. Let me see. Let's take help on this error though. So print place. That's good. So the problem is that okay. Okay, I think what I need to do is, do I need to wrap my O in quotes? Let's see. Oh nope. That is wrong. It says the problem here is that you are trying to count the occurrence of the letter O, but you didn't input it in quotes. In Python, if you want to refer to a string, you need to use the single quotes or double quotes. Since you wrote O without quotes, Python thinks you are referring to a variable name O, which hasn't been defined. Okay, but still is standing. So there's no capital letter O in pool. In the place pool, it is small letter O. That should do the trick right now. Aha, you can see that now I have the value of 3. Oh, thank you. So I kind of figure out that was the error there. Let's submit the answer and see. Great. So if I copy this bunch of codes and go ahead and paste it in my Jupyter notebook. So we created a string place that contains the keyword pull house. So we use the upper method. I won't say upper function. Say upper method to convert the pull house in small letters to a capital letter and save that in a variable called place up. So we printed out place and place up. Then we also now counted the number of O's, which is zeros, using the count method in the variable place, not the words. Okay, now let's see it in action. You can see we converted pull house to a capital letter pull house. Then we counted the number of zeros here, which is 3. That's pretty straightforward. List method. Okay, 8 seconds there. Okay. So this one said list method. So strings are not the only Python types that have method associated with them. So lists, uh, float, integers, and booleans are also types that come packaged with a bunch of useful methods. So probably all data types comes with a bunch of useful methods. So to know their methods, I think we can use the help function there to actually know the method associated with every object in Python. So you can now say that, so in this exercise, you'll be experimenting with index and count. So index to get the index of the first element of a list that matches its inputs, and count to get the number of times an element appears in a list. So you'll be working on the list with the area of different part of a house, which is areas, So use the index. So the instruction now says use the dot index method to get the index of the elements in areas that is equal to 20.0. Print out the index. So print out the index of the elements 20.0. So the index of the elements 20.0 is now going to be areas dot index. Let's see. Then I'm going to pass the index of 20.0 there, which is look at the index of 20.0. Now it now says print out how often 9.50 appears in areas. So same thing is going to be areas, which is the variable dot count. So I'm going to count the number of times 9.50 appears. 9.50 appears. So now we're going to print them out. So I'm going to wrap it in. Let me see if I run the code. So it's going to show one time. So I think I need to wrap it in print also. Print the index of this area variable, this value in the areas variable. So also print. If I run the code now, let's see again. I can see. So the index of area 20.0 is 2. Why number of times 9.50 appeared in our areas list is 1. Let's submit that. That's pretty nice. So these were examples of lists method that did not change the list they were called on. Okay. Sometimes if you're using the method, it's going to change the list they were called on. So let's see this in our Jupyter notebook here also. Okay. Easy peasy. Straightforward there. So let's continue. So list methods 2. So this is the last chapter. Okay, we see our packages in Python. Say list method 2. So most of the list method will change the list that they are called. And examples are append, remove, and reverse. So all this type of list method are going to change the list they are called on. So append that adds an element to the list it is called on. Remove that removes the first element of a list that matches the inputs, and reverse that reverses the order of the elements in the list it is called on. So you'll be working on the list with the area of different parts of the house areas. So use dot append twice to add the size of the pool house and the garage again. That is the size of the pool house. So use append twice. So to use append twice, it's going to be areas dot. So I'm going to add in the input I want to append to the areas. So I'm going to add in the figure. I'm going to add 24.5, 24.5. Then I'm going to be adding another append. Can't I add the two value at once? I'm thinking I should be able to add the two value at once. But let's see. Let's add it one by one. So use it twice according to the instruction. So 15.45. 15.45. Now print out areas. So print out areas. So we're going to print out areas. Okay. Reverse the orders of the elements in areas. We want to reverse the orders of the elements in areas. We just use the reverse. That will be areas dot reverse. Let's see. We need to provide the element of reverse. The list is called on. Okay. So I'm trying to see. I don't think we need to have any input there. So now print out areas once more. So we print out areas. So let's see the code in action. Aha. So you can see from here, the list was created. We appended it twice to add bolars and garage size. Then print out areas, which is the one first area there. Reverse the order of the elements, so the elements were reversed, you can see, from 50.5 from backward, and that was it. Interesting. Great. So that was pretty straightforward. But I think this method is going to change the elements according to the, so they say most list method will change the list they are called on. So append, remove, and reverse. They're going to change the list they are called on. So what did they change them to is what we need to know there. So let's see this in Jupyter Notebook also. You see, pretty straightforward here. Now let's move on. So they didn't tell us, so it said most method will change the list they are called on. But so it's to change the list to other methods that we need to figure out later. Interesting. So let's look at the packages in Python there.
By now, I hope you're convinced that Python functions and methods are extremely powerful. You can basically use other people's code to solve your own problems. That's amazing. However, adding all functions and methods that have been written up to now to the same Python distribution would be a mess. There would be tons and tons of code in there that you'll never use. Also, maintaining all of this code would be a real pain. This is where packages come into play. You can think of packages as a directory of Python scripts. Each script is a so-called module. These modules specify functions, methods, and new Python types aimed at solving particular problems. There are thousands of Python packages available from the internet. Among them are packages for data science. There's NumPy to efficiently work with arrays, Matplotlib for data visualization, and scikit-learn for machine learning. Not all of these packages are available. To use Python packages, you'll first have to install them on your own system, and then put code in your script to tell Python that you want to use these packages. DataCamp already has all necessary packages installed for you, but if you want to install them on your own system, you can use pip, for example, a package maintenance system for Python. If you go to this URL, you can download the file getpip.py. Next, you go to the terminal and execute python3 getpip.py. Now you can use pip to actually install a Python package of your choosing. Suppose we want to install the NumPy package, which you'll learn about in the next chapter. You type pip3 install NumPy. You have to use the commands python3 and pip3 here to tell our system that we're working with Python version 3. Now that the package is installed, you can actually start using it in one of your Python scripts. Before you can do this, you should import the package or a specific module of the package with the import statement. To import the entire NumPy package, you can do import NumPy like this. A commonly used function in NumPy is array. It takes a list as input. Simply calling the array function like this will generate an error though. To refer to the array function from the NumPy package, you'll need this. This time it works. The NumPy array is very useful to do data science, but more on that later. Using this NumPy dot prefix all the time can become pretty tiring, so you can also import the package and refer to it with a different name. You can do this by extending your import statement with as, like this. Now, instead of NumPy.array, you'll have to use np.array to use NumPy's array function. There are cases in which you only need one specific function of a package. Python allows you to make this explicit in your code. Suppose that we only want to use the array function from the NumPy package. Instead of writing import NumPy, you can instead write from NumPy import array like this. This time, you can simply call the array function like this. No need to use NumPy dot here. This from import version to use specific parts of a package can be useful, but you're also losing some of the context. Suppose you're working in a long Python script. You import the array function from NumPy at the very top, and way later, you actually use this array function. Somebody else who's reading your code might have forgotten that this array function is a specific NumPy function. It's not clear from the function call. In that respect, the more standard import NumPy as NP call is preferred. In this case, your function call is np.array, making it very clear that you're working with NumPy. Off to the exercises now, where you can practice different ways of importing packages and modules yourself. You're well on your way to becoming a Pythonista data science ninja.
Yes, I'll still stick to being a Python data analyst. But I think, oh, if you install the Anaconda Navigator, all the packages has been installed for you in the environment. I'll give it a shot though. Let's see. If I call out import numpy as np, it should be available already. Okay, let's give this a shot though. It should be. I don't need to install the packages before actually using them. Let's say an example. Let's say import numpy as np. Ooh, hopefully we won't get any error. No, we didn't. So that is the essence of this Anaconda Navigator. Once you install the whole Anaconda Navigator, all the packages are available within Python for you to use already. So you don't have to install the packages individually on your local machine. If I tried imports, let's try imports pandas as pd. Is another Python package. You see, it works straight. That's interesting. So I'll just delete this code here. Let me just delete this cell. Delete this cell. So we continue from here though. So it says import package. So let's say you wanted to calculate the circumference and area of a circle. Here's what those formulas looks like. So rather than typing the number for pi, you can use the math packages that contains the number. So for reference, hash is the symbol for exponential. For example, 3 #4 is 3 to the power of 4, and we give 81. Okay, interesting. So import the math package. So import the math. What is the math package? Use math.py to calculate the circumference of the circle and store it in C. Okay. So the math package. I'm going to say import maths. Import maths. I could say import math as empty. Okay, but let's just say import math though. Then it says use the maths.py to calculate the circumference of this in C. So 2 times 0.4 times circumference of a circle, which is 2 pi r. Yeah. So 2 pi r. So r is the radius. 2 times pi, this is the pi, and radius. So what is our radius for the circle? Radius of a circle is, I don't know the radius of a circle, but it says area is pi times r square. So the radius should be 2. Okay, the radius should be 2. You can see. Radius should be 2. You can see our radius there. Oh no, this is exponential raised to the power of 2. So our radius is 0.43. Let's reset the code. So import the math package. Math calculate the circumference of a circle. So the formula for the circumference is like 2 pi r. So 2 times pi times radius. So, but we don't know the radius of the circle. As there's an official value for radius of a circle. Oh, hold up. Hmm. So where is our radius now? That's the challenge. So I need to figure out what our radius is. Hmm. This is quite funny. Let's take it though. Okay, I need to refer to pi with mass.pi. Oh, okay. I need to refer to pi with mass.pi. Mass.pi. Okay. Okay. Calculate the area. The pi. So the pi is in the the pi is officially in the maths package. So I'm going to say maths.pi. Also here. Maths.pi. For this now, let's see it in action. Oh, ooh, we want it to, oh, I say comma here, not mad but dots. Voila. So we got our answer already. You can see the circumference is this and the area is this. So the pi that we're actually looking for, which is our pi. So our radius is this, but the pi was, okay, we do the value of pi, that is 22/7, but it's actually a value of 2, the decimal. I couldn't represent the decimal right now, but our normal pi from basic math one, but we refer to the pi from the math package. Let me try this in Jupyter Lab, Jupyter Notebook. Let's see. I hope the math package is also available here. Wow, so the math package is also available here. What I want to say, import maths as empty. So I'll now say empty.py here, empty.py, empty.py, then empty.py. Let's see it in action. So it still works fine. So I can actually, my package as an, I can abbreviate it. So I'm going to refer to it later in the code. Oh, so let's continue from here. So the circumference now area of the circle has been calculated for us. Interesting. Okay, just paste this again. And boom, we have it there. So calculate, see, so it is calculated already. Let's submit. Pretty straightforward there. So nice. If you know how to deal with functions from packages, the power of a lot of Python programmers is at your fingertips. So knowing how to use packages is pretty slick and important. So selective import. The general import like import math make all functionality from the math to you. However, if you decide to only use a specific package, you can always make your import more selective. So you can say from math import by. Okay. Will you actually import the pi for the maths package? So try the same thing again, but this time only use pi. Perform a selective import from the maths package where you only import the pi function. So from math import pi. So you can't use any other function from the maths function except pi. So it's for math import pi. Now use maths.py to calculate the circumference of circle and store it in C. You can see for math import pi as p. That should work. So rather than saying, let's say p, let's say p.py. I will refer to as pi. Let's see if it's going to work. I refer to it as p. Let's see. It works. It works. It works. Yeah. It works. So I could just abbreviate my pi as p, so I can actually refer to it later in my code to make it easier and simple to work with. Let's submit the answer and see. Correct. Interesting. We're getting good at this. Let me try it in my Jupyter notebook. We got same results. using different methods. Wow. Okay, so let's continue. So differentiating ways of importing. So there are several ways to import packages and modules into Python, depending on the import call. You have to use different Python code. So suppose you want to use the function inv, which is the lingua franca or ling-lang subpackage of the SciPy package. You want to be able to use this function as follows: my underscore inv lists of the list within a list and a list, which import statements will you need in order to run the above code without an error. Oh, hold up. So different ways of importing. Let me see. I think that's the last challenge here, which is different ways of importing. So different ways of importing. So there are several ways to import packages and modules into Python. So depending on the import call, you will have to use different Python code. So suppose you want to use the function inv, which is the ling-lang or LAIN ALG subpackage to the SciPy package. Okay, okay, which is subpackage to this SciPy package. You want to be able to use these functions as follows. Okay, you want to use the function as follows like this. Okay, so which import statements will you need to in order to run the above code? I can say from scipy.ling import my inv. Okay, I could say from scipy.linglang, which is the subpackage, import inv as my inv. Let's go for this. Correct. So that's actually so exactly. So you can use the subpackage. You can say from this scipy.linglang import inv. So we know that what we want to use the function inv, which is a subpackage, which is this ling-lang subpackage of SciPy. So this inv is in this ling-lang subpackage of the package SciPy. This is like the upper package and the lower package. So from scipy.linglang, so Python has methods. So every object or every data type, every element, every list in Python is an object, and an object as a method. So you need to figure out the type of method for each data type and for each object. As everything in Python is an object, then we also we learned all about packages in Python and how to import packages and different methods to import packages. And we looked at functions in general, which are just basic math functions that you're quite familiar with in Excel, in Power BI, in SQL also. So if you enjoy the channel, by up, hit that subscribe button and put on the notification bell so you'll be the first to know whenever I go live or drop a new content on the channel. As usual, I'll see you on the next video on the channel. So if you haven't studied from day one of Python, do well to go to the